Radius of convergence of a power series. Okay, so let us start. Suppose you are having a power series. Say let summation n equal to 0 to infinity e n z minus e raised to n. This is how we used to write power series. Be a power series, then there is a number. There is a unique extended real number r, that 0 is less than r less than infinity, such that the following holds. The first thing is, for all z with z minus e less than r, if your z minus e is less than r, then the series summation of en into say z minus e the whole raised to n converges absolutely. Okay, and the second thing is, for all z with, if your mod z minus e is greater than r, then we say that series is divergent. Summation en z minus e raised to n diverges. Okay, so these are the two things which we need to understand. So why this guy is so special, this r is so special, because if in this region, that is mod z minus e less than r, this series converges absolutely, and except that region, if you exclude that, that means you see this is a circle around z equal to e, it is a circle with radius r. So in this region your series converges absolutely, and in this outside of that region it is divergent. Correct? So that's why this value is very important. This thing is called radius of convergence. Okay, and there are so many methods to check whether radius of convergence exists and how to find this r. Okay, let us see that. Let summation n equal to 0 to infinity e n z minus e the whole raised to n be given. This is a power series. Assume that one of the following limits exist. As an extended real number. Okay, say the first limit is this: limit mod of en plus 1 upon en, that is equal to say rho. And second thing is limit mod of en raised to 1 by n, that is also equal to rho. Okay, if you remember, this is your ratio test and this is your root test. In ratio test you used to find this thing, an plus 1 upon an, and in root test you used to find this, and if this rho is less than 1, then you used to say something, it is convergent. And if you remember, right? So but यहाँ पे क्या है, then the radius of convergence of the power series given by r equal to 1 by rho. So this is your formula, that is rho inverse, you can write. Okay, so as easy as that. So whenever you see a series of this form, that is summation n equal to 0 to infinity en z minus whole raised to n, be given, assume that one of the following limit exists, either this or this. If one of them exists, then what is my radius of convergence? It is just inverse of this guy, inverse of this, correct? Yeah. So let us see some example now. Find the radius of convergence. Find the radius of convergence of the power series summation of en z raised to n, whose nth term, that is nth term of en is given by. The first one is 1 upon n square plus 1. Second one, you can say n raised to k upon n factorial. Third, 2 raised to n factorial upon 2n factorial. And fourth, you can take this 1 upon n raised to p for p greater than 0. And one more, let us take e raised to n plus b raised to n, where e is greater than b is greater than 0. Okay, so the question is find the radius of convergence of whether an is this. Okay, can you start with this? Start with the first, second, third, fourth, fifth, and tell me if you have any doubt in this. What about the first one? Let us see. Your en is given as 1 upon n square plus 1. So what do you think? You are having two people, either this limit or this limit. Which will be better here? Yes, whether ratio test or root test. There is nothing root here, so it is better to use ratio test, correct? So use ratio test. What is ratio test? Limit n tending to infinity mod of en plus 1 upon en. This is what you are supposed to find. So this is what limit n tending to infinity. This is already in natural number, so mod लगाने की ज़रूरत नहीं है. So it will be what? N plus 1 the whole square plus 1, and multiply by, it will be 1, that is n square plus 1 upon 1, correct? What do you think the limit is? What is this limit? The limit is 1, so that means your rho equal to 1. So what is radius of convergence? R equal to 1 upon 1, that is rho ka inverse, so it is again 1. Radius of convergence is 1 for this series, correct? Simple. What about the second one? N raised to k upon n factorial. What do you think? What will you do here? Ratio test or root test? You have choice, you can use any of them. Whenever you see factorial, it is better to use ratio test instead of root test. I'll include one more, n raised to n, 1 plus I raised to n, correct? Okay, can you do the second one by ratio test? Let us see. En equal to n raised to k upon n factorial. So let us use limit n tending to infinity en plus 1 upon en. So what will be this? Again it is positive, so you didn't have to struggle with mod. So ये क्या आएगा? n plus 1 raised to k upon n plus 1 factorial multiply by n raised to k into n factorial, correct? What do you see the limit is? What do you think? This is n plus 1 factorial. It can be breaked into n plus 1 into n factorial. So n factorial will get cancelled with this. N factorial will get cancel. And from here n raised to k, and this is n plus 1 raised to k. So you can combine these two people together. So it will be what? 1 upon n plus 1 multiply by, it will be 1 plus 1 by n raised to k. Correct? This is what you are having. Once you take limit and tend to infinity, this is okay, but this goes to 0. So this limit is 0. What do you see? What can you see then? Once this limit is 0. So what will be your radius of convergence? It will be infinity. Radius of convergence is infinity. That means what? This function is convergent, absolutely convergent everywhere. There is no specific circle. It is convergent everywhere. Okay, this is the second one. What about the third one? Third one is this 2 raised to n into n factorial upon 2n factorial. So it is also easy. You just have to use again ratio test. It will be good. And what about the fourth one? 1 upon n raised to p. P is any positive. P is greater than 0. That's they are saying. Same. Use the ratio test. Once you use the ratio test, what do you see? N plus 1 upon, so radius of convergence will be 1. Just quickly see that. I'll go to the fifth one. If you have any doubt, you can ask. See, n plus 1 raised to p, and this will be of this form. N plus 1 n raised to p upon n plus 1 raised to p. You will be having this, and this is converged to 1. So radius of convergence is 1. Correct? What next? Let us see this one. A raised to n plus b raised to n. So your a n is a raised to n plus b raised to n, where a is greater than b is greater than 0. Correct? So what do you think? What should you do? Ratio test, root test. A is greater than b. What about b by a? Is that less than 1? Correct? So can I take something out? If I take from here, if I take e raised to n common, so what will I have? If I take a raised to n common, I will be having 1 plus b by e the whole raised to n. Do you see? Now this guy, b by e raised to n, that is easy to do now. Can you see the answer now? Can I use a root test? Can I use root test? Yes. Limit n tending to infinity mod of en raised to 1 by n. So that will be limit n tending to infinity mod of n. That means what? This will be e raised to n by n. So this will be e, and this will be 1 plus b by e raised to n. This will be raised to 1 by n. Correct? And do you see where does this converge to? This guy converges to 0. Why? You remember that standard sequence. If your b is lying between minus 1 to 1, then b raised to n goes to 0. Correct? So I am using the same thing. B ki jagah pe I should use some different variable because you'll get confused with that. So if your c is lying between minus 1 to 1, then c raised to n goes to 0. So here my b by e, that is less than 1, and b by e raised to a, so this will go to 0. So you will be having just 1 plus 0, so it will converge to a. So what is your radius of convergence? radius of convergence is 1 upon a. Correct? Remember, whenever you are having like this, then the highest one, that is a is the highest one of them. So 1 upon a is the radius of convergence. Okay, which question was that? That was, I think, fifth. Yeah, fifth. Let us see sixth one. Sixth is en equal to n raised to n. Better to use what? Ratio test. Root test. En raised to 1 by n. So it will be what? Limit n tending to infinity. En raised to 1 by n. So it will be n, just n. So that goes to infinity. So what is my 1 upon infinity? So radius of convergence is 0. Is 0. What do you mean by radius of convergence is 0? That means it is a conversion only at that point, only at 0, nowhere else. Correct? Okay. One more was there. Consoles seventh. En equal to 1 plus I raised to n. Correct? यही है ना? 1 plus I raised to n. Yes. Now you see, better to use your root test. So let us see limit n tending to infinity en raised to 1 by n. Now you see, here is the main thing people used to do a mistake here. See, they are talking about mod en raised to 1 by n. So this is what? Mod of 1 plus I raised to n and raised to 1 by n. So this n and n will get cancelled, because you know that mod of z raised to n is same as mod z raised to n. Correct? So this will be equal to limit n tending to infinity mod of 1 plus I. But you have to find mod of 1 plus I now. What is mod of 1 plus I? That is square root of 1 square plus 1 square. That is root 2. And what is this is a value of rho. So what is radius of convergence? Radius of convergence is 1 by root 2. That's it. Simple as that. Do you see? Correct. Do I have any other question? Yeah. Let us do some more questions. In your practical, there are some also questions. Yeah. Find the radius of convergence of each of the following series. Of each of the following series. Okay. See the first one, summation n equal to 0 to infinity 2n z raised to, say, 2n. Z raised to 2n only. Second, summation n factorial z raised to 2n plus 1. Third, summation 1 upon n factorial z raised to 2n plus 1. Fourth, summation z raised to n factorial. Fifth, summation n square z raised to n raised to n. Sixth, summation 5 raised to n z raised to 3n. Suppose these are the question you are having. n equal to 0 to infinity लिख देना है यहाँ पे. Okay, let us see. The first thing you need to see that what do you want? You want to make your question of the form summation en z minus z naught raised to n. This should be your motto, because our rule is applicable once your a power series of this form, en z minus z naught raised to n. This should be of this form, then only you can apply. So let us see the first guy. The first guy is 2n z raised to n, that is summation 2n z raised to 2n, correct? What can you write this? You can write this as 2n z square raised to n, correct? Now can you see it is of this form, z square, no issue, radius of convergence. So my en is here 2n, so better to use ratio test, that is, and that is clear that वो 1 ही आएगा. Limit n tending to infinity mod of en plus 1 upon en, that is equal to 2n plus 2 upon 2n, so it is 1, correct? So radius of convergence are equal to 1. And what is see, this is radius of convergence. Question में actually they were asking only radius of convergence, so this is my answer, that is radius of convergence is 1. But if somebody asks you that what is interval of convergence, that means what? You go back to the first thing. What is this? This is called interval of convergence. Mod of z minus e, that is less than r, that is inside part, circle के inside का part, that is called interval of convergence. So for all the cases we can find the interval of convergence also, but here they were just asking about radius of convergence, so no issue. But if you want to find interval of convergence, here at the place of z I am having z square, so interval of convergence will be mod of z square, that is less than 1. And you know that z square is same as mod z cow square, that is less than 1. What can you say that? Mod z is less than 1. That means interval of convergence is minus 1 to 1. That's it. No, I cannot say like that. This is not true in real. So this is my interval of convergence. Just have to keep it like this only. This was first. Let us see the second one. Summation, it was n factorial z raised to 2n plus 1. Correct? What will you do here? Yes. How will you do that? First thing, I already told you, how do you want to keep your power series? You want to keep it as en into n factorial. Sorry, z raised to n, or z minus z naught raised to n. This is how you want to keep, and this is what you are having now. What will you do? What is your guess? What do you think? Yes? Do you see z raised to 2n plus 1? This is actually subsequence of this z raised to n. Correct? See en and e2n plus 1. What do you see the relation? e2n plus 1 is subsequence of en. So it is better to find the radius of convergence of this guy. That is also okay. इसका radius of convergence निकाला तभी भी चलेगा. Because this guy is subsequence of this. That means what? I just want to compare this whole thing with this. Summation n equal to 0 to infinity n factorial z raised to n. I just want to see with this guy and this guy, what is the similarity? Okay, so you may directly apply that radius of convergence का formula. You use whatever you want, either ratio test or root test. You can get that. Radius of convergence is 1 here. And what next? 1 upon n factorial, again radius of convergence is 1. Here it is 1. Coefficient is 1. It will be 1 only. N square, it is a polynomial, so it will be 1 radius of convergence. But the thing is, interval of convergence मैं नहीं पूछ रहा हूँ अभी. But again, this is n raised to n. This is again subsequence of n. This is 5 raised to n. Again same thing. Radius of convergence will be, I think, 1 upon 5. If you take nth root, that will be 1 upon 5. Yes. So do you observe something? Whenever you are having coefficient as a polynomial, the radius of convergence is 1 there, if you are having this as a polynomial. Okay. Yeah, so if you want, I can show you some practical